Hey fellow warriors, Mr. Ballard here. We are going to be doing Module 7, Lesson 11. We're doing more decimal expansions, this time of square roots of numbers, and we are putting those on a number line. So it sounds kind of like a lot, but it's not too terrible, so we are going to get going. Alright, so our first thing that we are going to do, it says place the number for our opening exercise, the number 28, on a number line. The part says make a guess to the first few values of the decimal expansion of the square root of 28. So since it says make a guess, I really want you to make a guess. And what that means is don't even use your calculator. If you had to guess where the square root of 28 would land on this number line in green, where would it land? Would it be between 1 and 2? Or would it be between 4 and 5, maybe 6 and 7, or maybe exactly on a number 2? Just take your best guess, maybe write that down so that we can come back to it later. What we're going to do is we're going to do example 1 together to help us build out to see where that would actually be. So for us, for example 1, it's saying consider the decimal expansion of the square root of 3. Okay, so the square root of 3. For our first approximation, what this is saying is they know the square root of 3 is bigger than the number 1 when you get an answer, and smaller than the number 2. And what that means is, and how they got that is the square root of 1 is 1. And then the square root of 4 is 2. They know it's going to fall between there. Okay? Just knowing those some basic facts. Okay? And that's where they got these numbers. Find the square root of that, find the square root of that, find the square root of that. 1 is smaller than 3, 3 is smaller than 4. Their answers would also have to fall in that same line. All right, so let's actually use our calculator and find the square root of 3. So for this calculator, I have to hit 3, then hit that square root button. And let's try it again. 3, square root. There we go. All right, so I get this really long number that would actually never end. So it is irrational. I can't write it as a fraction. But what I will do is I will write it out to that 0. So 1.7320. 1.732. So I'll kind of keep that in mind as my answer. And hopefully that makes sense to you, that this answer that we kind of truncated and cut it off right there, it is bigger than 1, but then smaller than 2. So that should hopefully make sense with that. Putting it on the second approximation is let's just say if we were cutting it off at the tenths place, because this number line only goes at the tenths, where would it go here? Well, looking at this, here's 1 whole, then 7 tenths, and if I cut the number off here, I see that the answer to the square root of 3 would go exactly right here on this number line. I could put 1.7, or I could say it's right here at that. I could write it like that. And if I wanted to write it as a number sentence, I could say 1.6 is less than the square root of 3, but the square root of 3 is less than 1.8. And I'm getting that from here and here. All right, taking it to a third approximation, still working with the square root of 3, instead of approximating to the tenths place, we're now going to approximate to the hundredths. So this one's not filled out for us, but I'll go ahead and fill it out. So the first one would be 1.70, and I'm getting that from here, because I know my number is actually technically a little bit bigger than that. And it's going to go all the way to 1.80, because I know it's smaller than that. So every other number gets filled in here. So I know it's not exactly on that 1.7. If I'm going to take it to that next more accurate level, it's going to be somewhere between these two. So 1.71, 1.72, and that's going to be hard to fit, but we'll make it work. 1.73, 74, 75, 1.76, diagonals starting to help. 7, 7, 1, 7, 8, and finally 1, 7, 9. So instead of truncating or rounding or even cutting it off at the tenths place, I'm now going to cut it off after the hundredths. And so now I would put that answer at 1.73 That's where it would go on the number line. Or I could write it like that. And if I'm getting more accurate than I did this time before, I would write it as such. 1.72 is less than the square root of 3, but the square root of 3 is less than 1.74, which I'm getting from right here. And that should make sense because it went exactly between those two on the number line. So moving forward, we come back to your original guess. All right. So where is the square root of 28 going to land on a number line? So for our first approximation, I'm going to just using some of my knowledge. I like using the ones where it has a nice clean whole answer. And what I mean by that is I know the square root of 25 is 5, and I know the square root of 36 is 6. Now, since I'm finding square roots, I know 25 is less than 28, but 28 is also less than 36. So I know the square root of 28 is going to be bigger than 5, but then it is going to be smaller than 6. So it's going to be somewhere between those two. So that's what I'm using for my first approximation. All right. So for my second approximation, hopefully you're seeing that they are going to the tenths place. All right. So let's go back to our calculator and let's find the actual square root of 28. So 28 square root. Get this really big number again, 5.2915. 5.2915, and I'll even throw that 0 in there, why not? So I'll come back and I'll write it over here. So 5.29150. So putting it on this number line that's already pre-filled for us, all right, going to the tenths place, it's right here. I'm just going to truncate. I'm not going to round, I'm just going to cut it off. I know that it would land right here. And if I'm writing a number sentence, I would say that the square root of 28 is larger than 5.1, but it is smaller than 5.3. That's how I could write that as a number sentence. Now next, the third approximation, because we just did the second, the third one here, instead of going to the tenths, we're going to now go to the hundredths. Okay, so going to the hundredths place, that is going to be starting at, I know that it's between 5.2, which is here, and then 5.3, which is here. So then this becomes 521, 522, 523, 524, 525, 526, 527, 528, and 529. Looking at my number, instead of truncating and cutting it off at the tenths, let's cut it off at the hundredths. So now putting this on this number line, I see that it should be located right here at 5.29. And I could write this above it just so that way you exactly see what I'm talking about. All right. So for the fourth approximation, you would see that we would go out to the thousandths place. And all you need to know for that is each place further we go out, the number's getting more accurate. So I know for this that the number is technically bigger than 5.29. So that would be my first one here, 5.290. And then it is smaller than 5.30. I could add that there. 0, 0. So, and then I would fill out this number line here. So 5291, 5292, 5293, and so on and so forth. So for this one, I would cut it off right after the thousandths place, 5.291. Okay, and that's truncating it, that's not rounding, it's just cutting it off. And so I would see that it would land exactly right here. And I could also write that above it. And so if I was writing a number sentence of this, I would say that the square root of 28 is greater than 5.290, but it is smaller than 5.292. All right, and I could keep going from there. It's not really necessary, but I could. And I kind of skipped this last one. I'm going to use a different color so it sticks out. For the one before, if I was writing a number sentence, I would say that the square root of 28 is larger than 5.29, but it is smaller than 5.30. Okay, so that's the lesson right there. That's it. So let me come back here, swing that thing around. Oh yeah. All right, so that's it. It's just taking square roots. They're irrational numbers, so they would go on forever. You could do this for days and days. The furthest we'll go out is the thousands place. And just know that the further you go out on a number line, the more accurate it gets. So all I expect you to be able to do is, if I give you a number and ask you to where would the number fall in a number line, if you were to find its square root, you follow that process right there. And if I ask you to take it out to the tenths, the hundredths, the thousandths place it on the number line. You also need to be able to fill in that number line to know where it goes exactly. I should be able to give you a blank number line like I had to fill out, and you have to know where to fill it in. So if you guys get any questions, hit me up. Take care. Talk soon.